नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्रुशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेसर। मैं आप सब लोग को स्वागत कर रहा हूं। जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो कंफर्मेशन है नहीं। ओके, सो मोटिवेशन कोट्स। गुड मॉर्निंग सर, गुड मॉर्निंग, नमस्कार, बढ़िया। सो लास्ट क्लास में हमने माइक्रो प्रोसेसर 8085 का कुछ क्वेश्चंस भी डिस्कस किया था। आज हम कुछ क्वेश्चंस और डिस्कस करेंगे। इसके साथ साथ हमने माइक्रो कंट्रोलर्स भी आज पढ़ाएंगे। ओके, सो ये हमारा कंटेंट है। So content of see, this is my telegram channel. You can join my telegram channel by scanning it. Okay, so now if you see, so this is a 8085 microprocessor and instruction set. This is a 8086 microprocessor and basics, and 8051 microcontroller भी basics आ सकता है गेट की इंस्ट्रूमेंटेशन के पेपर में। अगर आपने नॉन गेट एग्जाम लिख रहे हैं, सपोज यू आर राइटिंग एनी जेनको एग्जाम, ट्रांसको एग्जाम, स्टेट लेवल इलेक्ट्रिसिटी बोर्ड और स्टेट लेवल पीएचडी एंट्रेंस, एमटेक एंट्रेंस यूनिवर्सिटीज, एट दैट टाइम आल्सो दिस क्वेश्चंस आर आपको यूजफुल हो जाएगा। Okay, chalo, now let us go for this microprocessor. Microprocessor means the CPU on a single chip. Microcomputer means microprocessor combined with peripherals. Microcontroller means all microcomputer on a single chip. Okay, so now let us go for some questions. Fatafat some questions discuss karenge. Okay, so that we can go ahead with the questions. Somewhat the questions. Yeah, so try to answer this question. Consider the following registers: accumulator and flag register, B and C registers, D and E registers, H and L registers. Which of these 8-bit registers? Which of these 8-bit registers? Which of these 8-bit registers of 8085 microprocessor can be paired together to make a 16-bit register? Which of them can be paired together to make a 16-bit register? Can you answer these questions? Okay, so which of them are paired? Accumulator and flag register, B and C register can be paired. Actually, for programming purpose, we can use B and C. D and E we can pair, H and N we can pair. So 2, 3, 4 is the right answer. Option B is the right answer. Of course, program status word is the combination of accumulator register and flag register, but for programming purpose we won't use that. We won't use a 16-bit register. For 16-bit register we will use the BC and we will use the DE and we will use the HN. Okay, so let us go for some more questions. Please answer this question. Processor status word of 8085 microprocessor have 5 flags. It has how many flags total? 5 flags. Which are these 5 flags? Which are these 5 flags? Sign flag, zero flag, auxiliary flag, parity flag, carry flag. So what are the 5 flags? So if you see, if you see the 8085, so this is our total 8 bits. So these are 1, 2, 3, 1, 2, 3. So this is my carry flag. This is untouched. This is auxiliary. So this is a parity flag. This is don't care. This is auxiliary flag, and 0. This is a so sign 0, auxiliary, parity, carry flag. Okay, sign flag, 0 flag, auxiliary flag. So option A is the right answer. So there is no overflag here. There is no overflag here. Okay, so let us go for the next question. Answer this question. This is a match the following. Match the list 1 with the list 2 and select the correct answer using the codes given below. List 1, monitor program, assembler, mnemonic, program counter. List 2, used to indicate memory location, a combination of letters, symbols and numerals, a program that translates symbolic instructions into binary equivalent, and operating system. An operating system. So try to answer this question. So match the following questions. Use some time. ऑडियो वीडियो सब कुछ क्लियर है? Okay. Okay. What can be the answer? 4321. So monitor program, assembler, mnemonic, program counter. So program counter always points the address of the next instruction to be executed. So this is program counter. So this is 1. Next, mnemonic, a combination of letters, symbols and numerals. So this is number 2. Next, assembler. Assembler is a program that translates symbolic instructions to binary equivalent. So this is goes to 3. And monitor program is an operating system. So A goes to 4, B goes to 3, C goes to 2. So 4, 3, 2, 1. A goes to 4, B goes to 3, C goes to 2. So option A is the right answer. Option A is the right answer. Next. Answer this question. ESC 2016 का सवाल है. Try to answer this question. ESC 2016 का सवाल है. What is assembler directive statement used to reserve an array of 100 words? Array of 100 words. Array of 100 words. Memory and initialize all 100 words. See here, there are certain directives. So there are directives. These directives are called as not instruction. These directives are called non-executable statements. Directives are called as non-executable statements. non-executable statements. Okay, so they're not like instructions. Instructions are executable statements. So you have to understand that instructions are what? Instructions are executable statements. Instructions are executable statements. Instructions are executable statements. Directives are non-executable statements. Okay. So now I am asking, what is assembler directive statement used to reserve an array of 100 words? So there is an array of 100 words. Array is a separate memory location like this. So there are 100 words like this. The array of 100 words with 0, 0, 0 and give it name as storage. So this everything has to be, so this is on 0th location. So it has to be stored with a value 0, 0, 0. Okay, 100 words with 0, 0. So all must be duplicate with 0, 0, 0. So this 100th word, so this also must be duplicated with 0, 0, 0, 0. Okay, so how to initialize this array name? This array name is called storage. So I am taking it as storage. Storage is a name of an array that will store the word type. That will store the word type. DW means the data type, whatever that is stored in this is word. And these all words are duplicated with what value? Duplicated with 0. Question mark means unreserved, reserved but not value. Okay, so DUP 0. So option B is the right answer. Storage DW 100 position. Sorry, you have to represent the 100 position also. So 100 positions are duplicated with 0. So option B is the right answer. So let's go for the next question. Now answer this question. ESC 2011 का सवाल है. Make it fast. Answer please. What is the answer? See, what are the interrupts actually? 8085 interrupts. If you see, 8085 is having certain interrupts. So what are the interrupts of the 8085? If you check the interrupts of 8085, if you check, the interrupts are, first one is the trap. This trap is taken as RST 4.5. Next comes RST 5.5, RST 6.5, RST 7.5, and finally what we have is the INTR. So in this, the non-maskable interrupt is this. So this is a non-maskable interrupt. It is the highest priority interrupt. We cannot mask. non-maskable interrupt. Non-maskable interrupt. It is a non-maskable interrupt, my dear. Okay, so it's a non-maskable interrupt. So whenever this interrupt is occurred, there is a procedure to be executed. That procedure is having a standard address. So that address is calculated by multiplying with 8. So that 8 is the address. Why? Because in the memory, some 8 memory locations are reserved for it. So 8 5 is 30, 8 5 is 40, 8 4 is 32, 32 plus 4, 36. This is in hexadecimal. So 36 in hexadecimal, 36 in decimal. So this is 36 in decimal we are getting, but we have to convert into hexadecimal. So if you want to convert into hexadecimal, 36 divided by 16. So 16 2 ja 32 and remaining is 4. So 24H. 24H. So the right answer is this. Okay. So similarly, you can find for all. Okay. So this is a non-maskable interrupt. So now if I'm saying this 4.5 into 8, that is becoming as how much? 36 decimal. So that will be converted to 24 hexadecimal. Next, 7.5 into 8. So 7.5 into 8, if you see, 60 decimal, right? So you have to convert into hexadecimal. 16 3 is a 48, 16 4 is 16 3 is a 48. 48 means 12 will remaining. A10 B11 C12. A10 B11 C12. 16 3 is 48 plus 12. Next, 6.5 into 8. 8 5 is a 40. 52. 8 5 is a 40. 52 in decimal. So 16 4 is 16 3 is a 48. So 34H. 34H. Next, 5.5 is multiply with 8. 8 5 is 40. 0 44. So 44 in decimal. So we have to multiply with 16. 16 to 32. 32 plus 12. 2CH. Okay. So these all are having a standard address. These are already having standard address. So this INTR is, अरे यार थोड़ा ध्यान से देखो यार, एक बिट में 4-5 बिट आएगा आपको. So this INTR is non-vectored interrupt. जल्दी होना चाहिए, इंस्टेंट में होना चाहिए सबको. This non-vectored interrupt. So देखो इसमें कितना बिट्स आ रहे हैं, देखो. You are covering all the bits. So tomorrow if I have a question on 5.5, you can get that address. 4.5 इतना address हमको पता है ना. So this is trap is RST 4.5. INTR is the non-vector interrupt. One of the question. This is no address, no specific address. So this is the non-maskable interrupt. Non-maskable. So question asked for non-maskable interrupt. Non-maskable तो trap के लिए पूछ रहे हैं. Address कितना है? 24H. So option C is the right answer. So let us go for another question. Answer this question. ESC 2010 का सवाल है. 8085 microprocessor. The order of priority of hardware interrupts is dash. हाँ बताओ यार. Option B. Why? Because see the order. The highest order is always trap. So trap is this. So this is RST 4.5. Next this is RST 5.5. RST 6.5. So practice like this. This is RST 7.5 and this is INTR. So the highest priority is always this one. 1, 2, 3, 4, 5. So this is the order. RST 4.5, that means called trap. Trap తర్వాత 7.5, 6.5, 5.5. INTR is the last. So INTR should be last. Option B is the right answer. So that is a priority order. Miss मत करना उसको. Okay. Answer this question. Make it fast. Okay. So what is the right answer here? 14 bits are used. So 14 bits means what? 14 bits means we can address 2 power 14 memory locations. So 2 power 14 memory locations means how much it is? So 2 power 10 into 2 power 4. Okay. So 2 power 14 means how much it is coming? 2 power 10 means 1024. This is 16. Okay. 16,384 will come. So total memory locations are 16,384. So, but it will start from where? It will start from 0. It will end here. So this is 0th location. This is 16,383 location. So the right answer for this question here is option B hoga. Option B is the right answer. Okay. So let us go for another question. Answer this question. What is the answer here? For 16-bit address bus, if an 8 kilo RAM chip is selected, when A3, A4, A15 address bits are all are 1, then so 16-bit address bus he has given. So 16-bit address bus means we have to take 16 address lines. So we can take A0, A1, A2, A3. Next we can take A4, A5, A6, A7. Next A8, A9, A10, A11. Okay. Next A12, A13, A14, A15. So total 16 address lines is telling. For 16 address one, 8 kilo RAM chip selected. When A3, A4, A15 address lines all are 1. So 16-bit address lines. Na? So he is telling that 13, 14, 15. That irrespective of situation, 13, 14, 15 all are 1. Okay, 13, 14, 15 all are 1. And 8 kilo RAM chip. So 8 kilo RAM chip means what? So that can be taken as 2 power 3 into 2 power 10. So 2 power 13 address lines. So we have a 8 this much address bus. So this is the A0 to A13. So these are address line. So these are the address lines. A0 to A13, these are the address line. So but irrespective of the situation, हमारे पास 16 address lines है ना, 16 address lines में A13 A0 13 address lines means to A0 to A12 actually. A0 to A12. So these are the address lines. So these address lines corresponds to what addresses now? The minimum value is all zeros. The minimum address location is all zeros. The maximum address location is all ones. Okay, so this is also all 1. So now what happens now? So this is the F, this is the F, this is the F, 0 0 0. So this is what? 1 2 4 8. E na, A10 B11 C12 D13 E14. So this is 14 na, so 14 means E. So the right answer for this is E000 to E FFF. E000 to EFFF. Option A is the right answer. Option A is the right answer. Nobody has given the right answer. क्या हो गया भाई अंकुश? आंसर नहीं आ रहा है आपसे? बी कैसा होगा? हाँ सॉरी सॉरी सॉरी, परफेक्ट 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 परफेक्ट, करेक्ट करेक्ट करेक्ट, मैंने मिस्टेक कर दिया. दिस इज एफ. सुपर सुपर. ऑप्शन बी इज राइट आंसर. करेक्ट करेक्ट, ऑप्शन बी इज राइट आंसर. दिस इज एफ, आई फॉरगॉट. ऑल वंस मीन्स एफ ना. ओके, चलो लेट्स गो फॉर नेक्स्ट क्वेश्चन. Answer this question. A15, A14, A13, A12, A11. So A15, A14, A13, A12, A11. Okay, so these are the answer this question. This is a logic low. This is NAND gate. Think and answer. ऑप्शन सी हो रहा है. ओके, चेक. It's a NAND gate, na? So for a NAND gate, the chip select has to be 0. That means this must be all 1 should come here. So digital fundamentals. For a NAND gate, what is the input? For a NAND gate, if all inputs are 1, then output will be 0. So it should be 1. That means A15 should be 1. Here it should be 1 means A14 must be 0 here. Why? Because bubble is there. Next A13 must be 0. This will be 1. A12 must be 0. A11 must be 1. Okay, that is the syntax. So the logic circuit used to generate the active low chip select signal by an Intel 8085 microprocessor to address. So when you say Intel 8085 microprocessor is having 16 address lines. A0, A1, A2, A3. Next, A4, A5, A6, A7. Next, A8, A9, A10, A11. Next, A12, A13, A14, A15. Okay. So now what is the configuration? A15 must be always 1. A14 is 0. A13 is 0. A12 is 0. A11 is 0. So that is the situation, irrespective of other bits. So now the remaining other bits you can take it as 0, 0, 0, 0, 0, 0. These are the address lines. Okay. So remaining lines are going for the selection of the chip. So 1, 1, 1, 1, 1, 1, 1. So what has happens now? So this will be 8. This will be 8, 00. So this will be, so what is the answer? So 8, this is 8, 0, 0H. This is 8, this is F, F, H. The answer is option D is the right answer. What active high means? It should be 1. Active high means should be 1. So active low means CS bar is equal to 0. Active low. Active high means it will mention CS. CS is equal to 1. Active high. So then it should be 1 here. We'll use AND gate at that time. Active high CS means whenever this CS is equal to 1, that will be enabled chip. So there is a chip, a logic circuit is to generate the active low chip select signal. This chip select signal is used to select another chip. But to select that chip, this should be what? It is active low. That means when it is 0, it will be enabled. Okay. Active high means CS. It will be 1, then it will be enabled. In that case, we'll use AND gate. We can go for AND gate. When AND gate, all the inputs are something, output will be 1, like that. Okay. Got it? You check it यार. NAND gate को AND gate करके ये change करो. क्वेश्चन में NAND gate दिया. क्वेश्चन में NAND गेट दिया, क्लियरली एक्टिव लो चिप सेलेक्ट दिया, देन व्हाई यू आर गोइंग फॉर दैट? क्वेश्चन में क्या दिया? क्वेश्चन में NAND गेट दिया, क्वेश्चन में एक्टिव लो किया, देन व्हाई यू आर ट्राइंग फॉर एक्टिव हाई? NAND गेट का इनपुट्स को एक्टिव हाई आने के लिए क्या चाहिए? सो इफ यू से NANड गेट, सो फॉर NAND गेट व्हाट इज द सिचुएशन? सो दिस इज द A, B, this is Y. So for NAND gate 0, 0, 0, 1, 1, 0, 1, 1. So when all inputs are 1, output will be 0. Remaining all the cases it will be 1. So then this combination will be very complicated. So A15, A14, A13 you have to check like that. So it is going to be very complicated combination. Got it? You understand? At that moment we'll use AND gate. When we want to generate an active high signal, we'll go for AND gate. We'll go for active and high gate. Do you understand, Akshita? Sorry, Ankush. Is it clear? Chalo. Chalo. Do you understand or not? There is no compulsion that you should use NAND gate only. If you want to get an active high, so all should be 1 na. Output should be 1 means we'll go for all ones. All ones 1. So we'll go for CS. Got it? Okay. Chalo. Next question. Answer this question. Can you answer this question? Answer. Chalo. In 8085 microprocessor, a number of the form, some number is stored in the accumulator, is processed by the program. Assume Cy is equal to 0 as follows. So this is the first instruction, second, third, fourth, fifth, sixth, seventh, eighth. So what should happen? So for example, let us take some content. So let us take A is equal to, so let me take A is equal to, suppose before the program, let us take A is equal to some 21. So I am taking the A is equal to 21. Now and immediate FF. So first instruction outcome and immediate. So A is equal to 21, 0, 0, 1, 0. Next 21, 0, 0, 1. FF. So 1, 1, 1, all ones. So these are all ones. So when you perform AND operation, what I'm going to get? So wherever the 1 is there, that only will be allowed. So 1, so 0, 0, 0, 0, 1, 0, 0. So again A is equal to 21. Okay, done. Next, second instruction. B is equal to A. That means B is equal to 21. Okay, next, rotate accumulator left. So third instruction, rotate accumulator left. So left side we have to rotate. So how to rotate? So if you take again this one will be coming here. 1, 0, 0, 0 will come here. Next 0, 1, 0, 0. So rotation you have to do carefully. So how to do the rotation? So let me take again here. Carry flag is equal to 0 na. So carry flag is equal to 0 here. So थोड़ा patience से करना है. Carry flag is equal to 0. So 0, 0, 1, 0, 0, 1. So rotate accumulator to the left. So this is 1, 0, 0, 0, 4 zeros, 1, 0. Rotate accumulator left. Instruction lo carry ledu. So in instruction there is no carry. So carry should be involved in the rotation. So it will go to the 0 and 0 will come here. This is the 1, 2, 3, third instruction. Next, fourth instruction, again rotation. So 0 will come here, 0, 1, 0, 0, 0, 0, 1. 0 will go to the carry and again carry will come here. Done. Next, fourth time rotation. Sorry, third, 1, 2, 3, 4, fifth rotation, fifth instruction. Fifth time again rotation. So this is 0, 0, 1, 0, 0, 0, 0, 1 and 0 will come here. Okay, so finally we are getting 0, 8. Okay, fine. 8. Next, sixth instruction and immediate with FF. So 1, 1, 1, 1, 1, 1. So if you perform AND, again you are going to get 1, 0, 0, 0, 0, 0. Okay. Next, again AND immediate. Okay, what is this? Seventh instruction, 1 1 1 1 1 1 1. So we are going to get 0 0 0 1 0 0. Then finally is saying B, eighth instruction B. B is equal to what? 21 na? So 21. So 0 0 1 0 0 0 0 1. So what is the answer now? So this is 0 0 1 0 1 0 0 1. And you are going to get 29. So what is this? What is going to happen? Multiplication of accumulator content by 10, complement of accumulator content, multiplication of accumulator content by 9, rotation of accumulator content 3 times. That means it's only 3 times rotation na? So 1 2 3, that's it. There is no other things are happening here. So waste of time of doing this problem. See, its complement नहीं हो सकता है. 21 का complement क्या है? अगर 21 का complement बोले तो इसमें 1101 आना चाहिए, लेकिन अदर नहीं हो रहा है ना. Okay, so just you are rotating by 3 times. Is it clear, अंकुश जी? समझ में आपको? रेस्पॉन्स नहीं आ रहा आपसे? चलो, लेट्स गो फॉर सम मोर क्वेश्चंस. आंसर दिस क्वेश्चन. Move immediate a comma f0, r immediate ff, f star immediate f0. So first of all, what happens the first instruction? So a is equal to f0. That means 1 1 1 0 0 0. Next, r immediate ff. So it has to be immediately r with 1 1 1 1 1 1. So now if you perform r operation, so this will be 1, this will be 1, this will be 1, this will be 1. All are ones, so you are going to get ff. So this is the a now. Next, xr immediate with f5 f0, xr operation with whom? f0. So 1 1 1 0 0 0. So when you perform xr operation, what is going to happen? When you perform xr operation, when both are 1s, then only output will be 0, otherwise it will be 1. So here we are going to get 1, this is 1, this is 1, this is 1, 0 0 0 0. So the right answer is 0f. Right answer is what? 0. So this is the answer. Got it? जिंदा हो, जीवन में हो, अंकुश भाई. समझ रहे आपको? दिस इज वेरी सिंपल प्रोग्राम, आप कर सकते हैं आराम से. कुछ रेस्पॉन्स नहीं दे रहे आप. मूव इमीडिएट a comma f0. f0, this is f0 means 1 1 1 1 0 0. That is accumulator. Next, what is doing? r operation. r immediately with ff. That means accumulator में जो कंटेंट है ना, उसको ff से r operation करना है. So when you are performing r operation, any one of the input is 1, output will be 1. Okay, so 1 1 1 1, so 1 1, all ones, so that will become ff हो गया ना. Next is saying xr operation with f0. f0 means again f0. So what is xr operation? XOR gate आपको पता है ना? What is XOR gate? What is XOR gate? A B output 0 0 0 0 1 1 0 1 1. So this is 0. Okay, 0. That means that is this XOR operation. Okay. Now let us go for the another question. Please respond यार, response दीजिए, मुझे respond तो होना चाहिए ना. Very good questions I am discussing. Answer this question. This is a sequence. This is a number 1 instruction, number 2, number 3, number 4, number 5. Actually the program should be written like this, but I have written. Okay, so please, this is a sequence. So this is a sequence of the instructions. Miss mat karna. What are the contents of the accumulator and PSW register after executing the above set of instructions? IES 2010 का सवाल है. ESC 2010 का सवाल है. So फटाफट कर दो बेटा. move immediate a comma a. So this is accumulator. So first instruction, देखो first instruction, a is equal to double a. Double a h means what? 1 0 1 0 1 0 1 0, right? A means 1 0 1 0. Next, rotate right without carry. So right को rotate करना है. So imagine करो here carry flag है. So this is a very interesting program. So this is a carry flag. Right side carry flag है. Right now by default carry flag is equal to 0. So rotate right कैसा करना है? Right side. So that means MSB to this side. So this one should come here. 0 like that. Shift. So rotate right बोलो तो क्या है? MSB to LSB. LSB should go to carry. But carry should not come. Why? Because RRC mention किया. Instruction में C है तो rotation में carry को involve नहीं करना है. So LSB will come back to MSB. That is what. अगर इधर only rotate ROR is there, ROR rotate right, C नहीं है, then carry also involved. Just opposite. Instruction में C है तो rotation में C नहीं होना चाहिए. Instruction में C नहीं है तो rotation में C होना चाहिए. Like that it has to happen. समझ गया आपको? Okay. Now I am rotating. See the rotation बोलो तो पूरा circle घूमना है. So MSB will shift here. So this one will come here, 0 will come here, this one will come here, this 0 will come here, this one will come here, this 0 will come here, this one will come here. This 0 will go to the carry. समझ गया आपको? This 0 will go to the carry. But carry will not come into rotation. The same LSB will come here. That's it. So this is the second instruction. Okay, एक instruction हटा दो. Next comes the CMC. This time complement carry बोल रहे हैं. So carry flag will become 1 now. Okay, done. This also done. Next R immediate FF. So जो result आ गया ना उसको R operation कर लो with FF. 1 1 1 1. R operation क्या होगा? Any one of them is equal to 1. Output will be 1. So 1 1 1 1 1. All ones आएगा. Next, when you perform R operation, what happens to the carry flag? Can anybody tell me here? R operation, will it affect the carry flag? Anybody? What happens to the R instruction? After performing the R operation, will it affect? After R operation, please you can use it will reset the flags actually. You can check your Google chart or you can use the ChatGPT. So once you perform the OR operation, it will reset the carry flag. So carry flag will become 0. Please note down that. After OR operation, carry flag will be 0. Okay. So this instruction also done. Next, what we are doing now, rotate right to the carry side. So this one will come here. This one will come here. All ones will go like this. So it will go to the 1. This will be coming here. Carry will not be involved. So again, FF is coming. Increment A. So very interesting question. Now when you are incrementing A, what happens? Incrementing A means this should be plus 1. So when you plus 1 now, automatically all outputs will be 0. So accumulator becomes 0. So first of all, we can remove these first two options. Accumulator becomes 0. Why? Because what is asking accumulator and PSW. So accumulator becomes 0. But the important question is asking, what is asking is PSW. PSW means actually he has to mention the flag register. So what are the flags now? So we have to check the flags now. See the flags. Very interesting question. What are the flag status? Flags will be having 8 bits now. 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So what is the first flag in 8085? Carry flag. क्या भैया response नहीं आ रहा आपसे? Carry flag unused, parity flag unused, auxiliary flag unused, 0 flag, sign flag. Now देखो, sign flag will be MSB, that will be 0. 0 flag will be set. Yes, 0 flag will be set, that will be 1. Unused you take it as 0. Unused you take it as 0. Next, auxiliary flag also set. Why? Because 1 plus 1 1 0 here carry, 1 plus 1 1 0 here carry, 1 plus 1 1 0 here also carry. So auxiliary flag also will set. This one 0. Okay na? So number of ones are not there, so we can take it as 0. Parity flag, yeah, even parity na, number of ones is equal to 0, even parity. So next 0. Carry flag is also increment instruction. carry flag will not be set. Increment instruction carry flag will not be set. Okay. So answer is 01010100. So this is 54. So accumulator is 0. Accumulator is 0. And program this. Very good question actually. Very, very good question. Quality question. This is the level of the IES. क्या हो गया भैया? रिस्पांस नहीं आ रहा आपसे. अंकुश लडानी, are you there? These are the type of questions. You understand the instructions and outputs. Okay. Answer this. Addressing modes. These are the questions related to addressing modes. Direct addressing, register addressing, implicit addressing mode, register indirect addressing mode, immediate addressing mode. Can anybody answer this question? Answer please. Response दीजिए भैया. 10 members watch कर रहे हैं सेशन को. Bharat. Okay. So please respond. Otherwise, what is the purpose of these classes? So first of all, in the instruction, LXI is there. So LXI H means this HL register. H means HL register. We have to take X means pair. HL register will become as E400. So you are off in the instruction. IE means that is the immediate addressing mode. So B goes to 5. B goes to 5. Next, this is no operands. Only opcode itself is there. So CMC will go to the implicit addressing mode. So D goes to 3. D goes to 3. Next, move A comma M. Move A comma M is actually a indirect addressing mode. So it's not direct addressing mode. So register indirect addressing mode. So this goes to 4. So last one, LDA. So this address, LDA F1 series address. So it is a direct addressing mode. So A goes to 4, B goes to 5, C goes to 1, D goes to 3. Okay na? 4, 5, 1, 3. So 4, 5, 1, 3. Option D RA. Option D is the right answer. Excellent. Excellent. Option D is the right answer. चलो आंसर दिस क्वेश्चन. ESC 2013 का सवाल है. Yeah, excellent. Okay. So how this instruction will work? Just go through. Assume the accumulator and the register C of the 8085 processor contain A is equal to F0, C is equal to 0F. What will be the content of accumulator after execution of the instruction ADC? So this is add with carry. ADC means add with carry. It is not only A plus C. We should add with carry also. Okay. Assume that the accumulator in this register C of the 8085 microprocessor contain respective. Sorry, it's add C na. Okay, sorry. It is add C. So space is not there. Add C means A plus C. So that means 1, 1, 1, 1, 0, 0, 0. This is 0, 0, 0, 1, 1, 1. Answer is FF na. Very simple question. इसमें क्या गलत है? Answer is FF. Okay. चलो बेटा, these are some questions. Now I am going for some interesting thing, that is a 8051 microcontroller. So I think all of you have studied 8051. I don't know how much of you studied, but 8051 is also very very important with respect to competitive exams, gate exam, interviews, सबके लिए. So one shot में just I want to give you the basics of 8051 microcontroller. What are the microcontrollers? How they will work? So if you see the microcontroller, first of all, we'll start with the fundamentals. We'll start with the fundamentals. So see here. So if you see the microcontroller, basic differences. What are the differences between microprocessor and microcontroller? So microcontroller is different, microprocessor is different. Okay. So if you see here, this is a microprocessor, this is a microcontroller. Okay. So microprocessor is a CPU. That's it. But इसके लिए RAM, ROM, IO ports इसमें internally नहीं है, पूरा बाहर है. Now when you club all this, when you interface all this, a microprocessor, RAM, ROM, IO ports combine करके एक smallest area पर fabricate कर दिया, उसको हम microcontroller बोलते हैं. CPU, RAM, ROM, IO and timer all on a single chip. Next, designer can decide on the amount of RAM and RAM, but here fixed. That's why it is called fixed. आपका application के लिए कितना चाहिए उतना ही बस. Fixed amount of on-chip RAM, fixed amount of on-chip RAM and IO ports. Next is the versatility. It is application specific. Always remember, it is ASIC. It is not for multiple purpose. Some people are only for specific purpose. They will do that task only. But there are other people that are for general purpose. So they are general purpose. Microprocessors are general purpose. These are single purpose. Okay. Chal. Next, let us go for the another question, another category. So these are block diagram. So examples. These are fundamental definition. Always मैं आपको बोलता हूँ इंटरव्यूज में आपको पूछता है, क्योंकि अगर बीटेक के आ गया कोई ना कोई इलेक्ट्रॉनिक कंपनी को आपको इंटरव्यू को जा रहे, सपोज यू आर गोइंग फॉर एनी इंटरव्यू ऑफ एनी एम्बेडेड सिस्टम्स कंपनी लाइक इंटेल, कैपजेमिनी, AMD, वेदा माइक्रो सिस्टम्स, FPGA कंपनीज, VLSI कंपनीज, एनी कंपनी में आप जा रहे हैं, आपको फंडामेंटल क्वेश्चंस पूछते हैं. माइक्रोप्रोसेसर का डेफिनेशन है CPU ऑन ए सिंगल चिप 8085, 8086. नेक्स्ट, माइक्रो कंप्यूटर का डेफिनेशन है microprocessor assembled with all other peripherals. Microcontroller को क्या बोलते हैं? Entire microcomputer is fabricated. The entire microprocessor is fabricated here. Okay. So microcomputer on a single chip is called 8051. So 8051 का block diagram, see here. Actual embedded systems का programming जो है ना, अगर आपने embedded systems company को जाना चाहते हो, or you want to work for a good Intel company or a Motorola company, Qualcomm company, टेलीकम्युनिकेशन कंपनीज, आपको माइक्रो कंट्रोलर का प्रोग्रामिंग जरूर आना है. आपका एकेडमिक्स में क्या पढ़ाते हैं मुझे पता नहीं. एकेडमिक्स एंड इंडस्ट्री में बहुत सारा ब्रिज है, बहुत सारा गैप है. सॉरी, आपका एकेडमिक्स में आपको ब्लॉक डायग्राम पढ़ाते हैं, इंस्ट्रक्शन सेट पढ़ाते हैं, लेकिन इंडस्ट्री में क्या है ना, ये नॉलेज से आप कुछ ना कुछ कंट्रोल करना चाहिए. एक स्टेपर मोटर को रोटेट करना चाहिए, स्क्वायर वेव जनरेट करना चाहिए, बहुत सारा एप्लीकेशन है माइक्रो कंट्रोलर के ऊपर. सो दैट्स व्हाई आई सजेस्ट टू द स्टूडेंट्स, व्हेनेवर यू आर इन द कॉलेज एकेडमिक्स, the labs, if you have good labs, please utilize the labs, so that अगर आपके पास laboratories established है, आपके कॉलेज NITs IITs है, तो laboratories को यूज करो. ओके, गेट का प्रिपरेशन तो होने दो, वो पैरेलल में होने दो. आपको शाम को और सुबह 7 बजे से 9 बजे तक, डेली मॉर्निंग 7 to 9 एंड इवनिंग 7 to 9 यू कैन अलॉट फॉर द गेट क्लासेस. बट मॉर्निंग 9 to इवनिंग 4 अगर आप एकेडमिक्स में है, तो एकेडमिक्स में कॉलेज में लैब्स जो है ना, वो लैब्स को अच्छी तरह से यूज करो, उधर फैकल्टी से अच्छी डिस्कशन करो एंड डेवलप सम प्रोटोटाइप्स, डेवलप सम प्रोजेक्ट्स, क्योंकि फैकल्टीज के पास बहुत सारा नॉलेज रहता है लैब रिलेटेड के लिए. एक बार आपको बीटेक हो गया ना, बीटेक होने के बाद आपको लैब्स को एक्सेस करने के लिए चांस ही नहीं रहता. आपको घर में यू कैन नॉट एस्टैब्लिश अ लैब, VLSI लैब, FPGA लैब, माइक्रो कंट्रोलर्स लैब, ड्रोन्स लैब, यू कैन नॉट एस्टैब्लिश. सो आपको कॉलेज में वो फैसिलिटी है. सो अगर फैसिलिटीज है तो यूज करो, अगर फैसिलिटीज नहीं है तो भी आप कुछ सिमुलेटर्स डाउनलोड करके सिमुलेटर से प्रैक्टिस करो. क्योंकि अगर आप कोई ना कोई इंटरव्यू को जा रहे हैं ना, इंटरव्यू में आपको पूछते हैं, they know that you are academically you are strong. You are preparing for gate means, if you are preparing for gate means automatically academically you will become strong. Yes or not? Academically you will become strong only. Academically you will become strong. Why? Because हमने fundamentals पता, fundamentals हम teach कर रहे हैं ना, लेकिन programming skills आप practice करना है. Okay, चलो बेटा. So these are the block diagram. So if you see, this is a 4 kilo ROM. It is having on-chip RAM and off-chip RAM. On-chip, off-chip बोलो तो क्या है? On-chip बोलो तो internal, off-chip बोलो तो external. एज आई टोल्ड यू माइक्रोप्रोसेसर के लिए मेमोरी इंटरनल नहीं है, लेकिन माइक्रो कंट्रोलर के लिए मेमोरी इंटरनल है. So it is having on chip RAM and on chip ROM. So it is having 128 bytes of RAM. It is having 128 bytes of RAM and it is having 4 kilobytes of ROM. It is having 4 kilobytes of ROM. So next, externally, if it is not sufficient, there is external memory, external of 64 KB RAM. It is having 64 KB RAM and 64 KB ROM. So this is external. 64 KB RAM and 64 KB ROM external. Okay, so this one is also having 4 IO ports. What are the ports? Port 0, port 1, port 2, port 3. So port 0, port 1, port 2, port 3. What are the ports? See, हमारा सिस्टम में पेन ड्राइव कनेक्ट करते हैं, यूएसबी ड्राइव कनेक्ट करते हैं, माइक को कनेक्ट करते हैं. So these are called ports. So ports is a location where the data transfer takes place from microprocessor or microcontroller to the external world to this. Okay, so port 0, port 1, port 2, port 3. There are 4 ports. Next comes serial data communication. So TXT and RXT. TXT and RXT. Okay. Next comes this oscillator. There is a crystal oscillator which will generate a frequency of 11.092 megahertz. So this is the frequency 11.092 megahertz. Okay. So that's it. These are the features. And we're having 2 timers, timer 0 and timer 1. Timer is a register of 16-bit. So this is called timer low 0. This is called timer high 0. Timer 0 low, and this is timer. Okay, so please make a note of this. It's a very interesting block diagram. Next, so still I am giving the features. It is having 4 kilobytes of ROM, which is called internal ROM and also called as on-chip ROM. It is having 128 bytes of RAM, which is called internal RAM. It is also called as on-chip ROM. 4 8-bit IO ports, port 0, port 1, port 2, port 3. Next, 2 16-bit timers, timer 0, timer 1. Sorry, mistake, timer 1. Okay, timer 1. Next, serial interface. So serial, what is serial interface? अगर ये माइक्रो कंट्रोल से आप बाहर वर्ल्ड से, एक्सटर्नल वर्ल्ड से कम्युनिकेट करना चाहते हो, शेयरिंग करना चाहते हो, इंफॉर्मेशन शेयरिंग करना चाहते हो, रिसीव एंड ट्रांसमिट के लिए 2 पिंस रहता है. सो दे आर कॉल्ड ट्रांसमिट एंड रिसीव. सो दिस इज TXD and this is RXT, transmit data and receive data. Next, in addition to this internal RAM, अगर ये internal memory आपको sufficient नहीं है तो आपको external memory भी है. 64 KB external code memory space, 64 KB external ROM memory. So 64 KB both 64 KB external code memory, data memory. देखो 64 KB external code memory space को external ROM बोलते हैं, इसको ऑफ चिप ROM भी बोलते हैं. Next, 64 के डाटा मेमोरी बोलते हैं, इसको एक्सटर्नल रैम बोलते हैं, इसको ऑफ चिप रैम भी बोलते हैं. सो डोंट कंफ्यूज. अगर ऑब्जेक्टिव क्वेश्चन पूछा ऑन चिप एंड ऑफ चिप, आपको क्लैरिटी होना चाहिए. ऑन चिप रैम 128 बाइट्स. सो ये प्रिंटिंग मिस्टेक अगेन. ऑन चिप रैम 128 bytes, half chip RAM 64 KB, on chip ROM 4 KB, half chip ROM 64 KB, and we're having 8 data lines and 16 address lines. How many data lines? 8 data lines and how many address lines? 16 address lines. 8 data lines and 16 address lines. D0 to D7, A0 to A15. नोट कर दो बेटा, पूरा कंटेंट आपके लिए, ये इंटरव्यू के लिए बहुत इंपॉर्टेंट कंटेंट है. अगर आपने इंटरव्यूज अटेंड करना चाहते हो, इंटरव्यूज में एक क्वेश्चन आपको जरूर पूछेगा. Any doubts? Shall we move for the next? करेक्शन कर दिया ना, आई हैव करेक्टेड ना, th1 t, okay, sorry, is timer low, timer high, so timer high here, typing mistake, yeah, nice, two timers bhaiya. So generally timers are used for delay operation. This is timer 0, this is timer 0, this is timer 1. Okay, so this is what happening. So this is timer 0, this is timer 1. So this is timer low 0, this is timer 0 high, this is timer 1 low, this is timer 1 high. 16 bit total मिला के 16 bit. So this is 8, this is 8, this is 8, this is 8. Done? Yeah, thank you. चल, yeah, देखो diagram. So as I told you, on chip and off chip clarity देखो. On chip 128 bytes of RAM, on chip 4 KB ROM, half chip 64 KB, AB 64 KB. So 16 address lines, so 64 KB. Why? Because 16 address lines na, 8051 is having 16 address lines, 2 power 16 memory locations. 2 power 16 means 2 power 6 into 2 power 10, one memory location comes 8 bit, 8 bit means byte, so 2 power 16 means 64K, 64K. So that's why external memory is 64K. Okay, so enough for today. Okay, thank you. Basics enough.